Welcome to the Bedtime Lab, dear friend. You've arrived in a place where the wonders of the universe are yours to explore, with each softly spoken word lulling you into a serene state of sleepy curiosity. I invite you to settle in and ponder this question: where are you joining us from tonight? Feel free to share in the comments below. It's always lovely to know where our friends are listening from. Now, let me share something intriguing about our tiny celestial neighbor, Pluto. Imagine a place where the sky is a tapestry of eternal twilight, with the sun so distant it resembles just another star. This is Pluto, a world that has long captured our imagination. Did you know that Pluto takes about 248 Earth years to complete a single orbit around the Sun? That's longer than the entire history of the United States. Speaking of which, the orbit of Pluto is so eccentric that it sometimes comes closer to the Sun than Neptune. Can you envision a dance so precise and intricate? Here's something fascinating. Pluto's surface is a patchwork of ice plains, mountain ranges, and craters. Among the most mesmerizing features is the heart-shaped glacier known as Tombaugh Regio, which covers nearly 1/3 of Pluto's surface. This icy heart is made primarily of nitrogen ice, and it shifts over time, like a frozen heart that beats ever so slowly. And here's another little secret from the cosmos. Pluto has a companion in its dance through space, a moon named Charon. What's truly remarkable about Charon is its size. It is so large compared to Pluto that the two bodies orbit a point outside of Pluto itself, a cosmic ballet performed by no other planet and moon in our solar system. Can you imagine such a delicate balance? Speaking of companions, Pluto is not alone in its icy realm. It belongs to the Kuiper belt, a vast region beyond Neptune filled with small icy bodies. Let me share an interesting fact about this region. The Kuiper belt is like a cosmic attic, full of dusty remnants from the solar system's formation. It's home to countless icy objects, some of which may even be larger than Pluto itself. Did you know that the Kuiper belt stretches for more than 4.5 billion kilometers from the Sun? That's about 30 times the distance from Earth to the Sun. Within this immense span are not just icy rocks, but also dwarf planets like Eris and Makemake, each with its own set of mysteries waiting to be uncovered. Here's something that might surprise you. The Kuiper belt is believed to be the original home of some comets we see streaking through our night sky. These icy travelers occasionally get nudged from their orbits and make their way toward the Sun, creating beautiful tales of light for us to marvel at. And speaking of marvels, have you ever pondered how cold it must be out there? On Pluto, temperatures can plummet to nearly -230 degrees Celsius. That's cold enough to freeze the atmosphere, forming a thin layer of frost on its surface. Imagine a place where the air itself can freeze. Now, let's dive deeper into the wonders of Pluto's atmosphere. Did you know that it is primarily composed of nitrogen, with traces of methane and carbon monoxide? During its orbit, as Pluto drifts closer to the Sun, these gases can warm and expand, creating a thin temporary atmosphere that hugs the icy surface. And speaking of surface features, Pluto is home to an array of towering mountains, some reaching heights of up to 3.5 kilometers. These mountains are not made of rock, as you might expect here on Earth, but of water ice. In the frigid temperatures of Pluto, water ice is as hard as granite. Here's something else intriguing. Scientists believe that beneath Pluto's icy exterior may lie a subsurface ocean. Can you imagine a hidden ocean on this distant dwarf planet? Such a discovery could change our understanding of where life might exist in the universe. And as we come full circle, let's return to the Kuiper belt for a moment. This region is a treasure trove for astronomers seeking to understand the early solar system. Unlike the planets closer to the Sun, objects in the Kuiper belt have remained relatively unchanged for billions of years. They are time capsules, preserving the secrets of our solar system's infancy. As you drift towards sleep, let these thoughts of distant worlds and icy realms gently rock you into a deeper dreamland. The universe is vast, and there's so much more to explore. Thank you for joining me here in the Bedtime Lab, where the cosmos whispers its secrets, and you, my dear friend, are always welcome. Until next time, sweet dreams and celestial wonders await you. Let me take you on a journey into the intriguing details of Pluto's orbit, a celestial path that's as unique as it is fascinating. Did you know that Pluto's orbit is tilted at an angle of 17 degrees to the plane of the solar system? This means it spends a lot of time either above or below the orbits of the other planets. Imagine a path that weaves in and out like a cosmic roller coaster, challenging our perception of what a typical planetary orbit looks like. Speaking of unusual orbits, let me tell you about the Kuiper belt's own distinctive features. The Kuiper belt is not a flat disk as you might envision, but a donut-shaped region with a thickened middle. It's a bit like a celestial cloud, full of countless icy bodies that dance in a slow, frozen waltz around the sun. This region is populated by a variety of objects, some of which are locked in what scientists call resonant orbits with Neptune. In such orbits, these objects complete a set number of revolutions for every orbit of Neptune, creating a harmonious cosmic rhythm. Now, let's turn our gaze back to Pluto and its fascinating relationship with sunlight. Given Pluto's vast distance from the Sun, sunlight is about 1,600 times dimmer than what we experience on Earth. Imagine a perpetual twilight, where the sun is merely a bright star in the sky, casting a gentle glow over the icy landscape. This dim light creates a serene, almost ethereal environment on Pluto, perfect for pondering the mysteries of the universe. Here's an interesting tidbit. Pluto's day is quite unusual as well. A single day on Pluto, from sunrise to sunrise, lasts about 6.5 Earth days. That's because Pluto rotates slowly on its axis, much like a graceful ballet dancer spinning in slow motion. This leisurely pace means that time on Pluto stretches out, offering a long, lingering dance of light and shadow. Speaking of time, did you know that Pluto's atmosphere is dynamic and ever-changing? As the dwarf planet moves closer to the Sun in its orbit, the surface ice sublimates, turning directly into gas and creating a thin atmosphere. But as Pluto drifts further away, this atmosphere can freeze and fall back to the surface as snow. It's like a cosmic breathing, a rhythm of sublimation and precipitation that follows the dwarf planet's celestial journey. And here's a fun fact about Charon, Pluto's largest moon. It's so closely connected to Pluto that both bodies keep the same face towards each other as they orbit. This means if you stood on Pluto, you would always see Charon in the same spot in the sky, never rising or setting. It's a perpetual cosmic dance, a silent shadow that never leaves Pluto's side. Speaking of shadows, have you ever wondered about the color of Pluto? Pluto's surface is a fascinating palette, painted with shades of red, white, and black. The reddish hue comes from tholins, complex organic molecules formed when sunlight interacts with methane. These tholins give Pluto its characteristic rosy tint, a sign of chemical processes that have quietly unfolded over eons. Turning our thoughts to the broader Kuiper belt, there's a curious feature shared by many of its inhabitants: a variety of surface colors. These range from red, like Pluto, to more neutral grays. Some objects are even blue, a rare color in the solar system, hinting at diverse compositions and histories. It's as if the Kuiper belt is a cosmic artist's palette, showcasing the intricate beauty of our solar system's distant outskirts. Now, let me share something truly fascinating. Beyond Pluto and its well-known companions, there are likely many more undiscovered dwarf planets in the Kuiper belt. Some scientists estimate there could be hundreds, each with unique characteristics and stories to tell. These hidden worlds beckon to us with the promise of new discoveries, waiting patiently in the frigid darkness of space. Lastly, consider the idea that the Kuiper belt is not just a static collection of icy bodies, but a dynamic system. While most objects remain in stable orbits, some are occasionally disturbed by the gravitational influence of Neptune. This can send them spiraling inwards as comets, bringing them closer to the Sun and, eventually, to our night skies. These comets are like messengers from the Kuiper belt, sharing whispers of their deep space origins as they grace us with their fleeting beauty. As you continue to unwind and let your mind drift, remember that each fact is a step closer to understanding the vastness of space. These snippets of knowledge about Pluto and the Kuiper belt paint a picture of a distant realm where time moves differently. Colors tell stories, and the dance of celestial bodies echoes the rhythms of the universe. So as you gently drift into slumber, keep dreaming of these far-off wonders, each one a lullaby from the cosmos itself. Let me take you further into the mysteries of Pluto by sharing something you might not know. Pluto has 5 known moons. Besides Charon, the largest, it has 4 smaller companions named Styx, Nix, Kerberos, and Hydra. These moons are much smaller and irregularly shaped, resembling potatoes more than spheres. Their orbits are chaotic, dancing unpredictably around Pluto in a cosmic ballet that challenges our understanding of gravitational dynamics. Speaking of orbits, here's a curious detail. Pluto's path around the Sun is so elongated that there are times when it is closer to the Sun than Neptune. This happens for about 20 years of its 248-year orbit. It's a cosmic game of tag, where Pluto briefly steps into the territory of the 8th planet before retreating to its icy domain. Did you know that the New Horizons spacecraft, which provided us with so much information about Pluto, traveled more than 4 billion kilometers to reach this distant world? Launched in 2006, it took nearly a decade to arrive, passing Jupiter along the way to gain a gravitational boost. Imagine the anticipation as it approached Pluto, ready to unveil secrets that had been hidden in the shadows for so long. And here's something that might surprise you. Pluto's heart-shaped glacier named Sputnik Planitia is composed of nitrogen ice. This vast frozen plain is constantly reshaping itself, with glaciers flowing and surface features changing over time. It's a living landscape, whispering tales of geological activity under a sky dotted with distant stars. Let me tell you about another fascinating aspect of Pluto. Despite its cold, distant location, Pluto has been found to have blue skies, much like Earth. This is due to the scattering of sunlight by haze particles in its atmosphere. Can you imagine standing on Pluto's surface and looking up at a sky tinged with blue, a gentle reminder of home so far away? Now, let's turn our attention back to the Kuiper belt. This region isn't just a collection of icy bodies, it's also home to some of the oldest objects in the solar system. These ancient relics are remnants from the solar system's formation, frozen in time and space. By studying them, scientists hope to unlock secrets about the early days of our cosmic neighborhood. Here's a thought-provoking fact. While Pluto is the most famous resident of the Kuiper belt, it's not the largest. That title belongs to Eris, another dwarf planet that resides even further from the Sun. Eris is slightly smaller in size but more massive than Pluto, highlighting the diversity of these distant, icy worlds. It's intriguing to think about how these objects interact with sunlight. The light they receive is so faint that it takes more than 5 hours for sunlight to travel from the Sun to the Kuiper belt. Imagine being in such a remote place where the warmth and light we take for granted are reduced to a gentle, distant presence. Speaking of remoteness, did you know that the Kuiper belt is home to a class of objects known as cold classicals? These bodies have remained largely undisturbed since their formation, preserving their original characteristics. It's like finding a time capsule from the early solar system, providing insights into the conditions that existed billions of years ago. As we delve deeper into the wonders of this distant realm, consider the fact that the Kuiper belt is thought to contain more mass than the asteroid belt between Mars and Jupiter. Despite its distance and dimness, it's a place of surprising abundance, a reminder of the vastness and richness of the universe waiting to be explored. Have you ever wondered about the names of the objects in the Kuiper belt? Many are named after mythological figures, a tradition that adds a layer of romance to these icy travelers. From Greek gods to indigenous deities, each name tells a story connecting our human history to the cosmic dance of the solar system. Let me share a captivating thought. Some scientists believe there might be a yet undiscovered planet lurking in the far reaches of the Kuiper belt. Often referred to as Planet 9, this hypothetical world could explain the peculiar orbits of some Kuiper belt objects. It's a tantalizing mystery, a celestial enigma that continues to spark the imaginations of astronomers. Now, let's drift back to Pluto for a moment. Did you know that it has a polar region covered in a layer of methane ice? This frosty cap reflects sunlight, giving it a bright appearance against the darker surface around it. Imagine a landscape where methane, rather than water, forms the icy plains and sculpted hills. Finally, consider this. The Kuiper belt is not only a frontier for space exploration, but also a frontier of ideas. It challenges our definitions of what it means to be a planet, prompting us to rethink our place in the cosmos. As you ponder these facts, let your mind wander through the vast expanses of space, where the known and unknown intermingle in an endless dance. Let me take you on another enchanting journey through the icy realms of Pluto and the Kuiper belt. Did you know that Pluto's atmosphere is much thinner than Earth's but surprisingly complex? It's composed primarily of nitrogen, with traces of methane and carbon monoxide. This delicate atmosphere expands and contracts as Pluto moves closer and further from the Sun. Imagine a celestial breath, gently inhaling and exhaling over a span of centuries. Here's something that might intrigue you. Pluto has seasons, much like Earth. However, these seasons last over a century each, due to its lengthy orbit around the Sun. Can you imagine living through a spring or autumn that extends for over 100 years? The slow, rhythmic changes are a testament to the patience of the cosmos. Speaking of celestial rhythms, did you know that Pluto's largest moon, Charon, is so massive relative to Pluto that they form a binary system? This means they orbit a common center of gravity that lies outside of both bodies. Picture two cosmic dancers, forever locked in a graceful duet against the backdrop of the universe. Now, let's consider the fascinating fact that there are Kuiper belt objects, or KBOs, that have moons of their own. In some cases, these moons are nearly as large as the objects they orbit. It's a reminder that even in the quiet, distant reaches of the solar system, complexity and diversity abound. Have you ever wondered about the color of these distant worlds? Pluto, for instance, displays a range of hues from pale yellow to deep red. These colors are caused by tholins, complex organic molecules that form when cosmic rays and ultraviolet light from the sun interact with methane on Pluto's surface. It's as if the universe has painted these icy landscapes with a cosmic palette. Let me tell you about another intriguing aspect of the Kuiper belt: its dynamic nature. Despite its icy calm, this region is a place of constant change. Collisions between KBOs can create smaller fragments, adding to the population of this expansive region. Imagine the slow-motion dance of icy bodies, occasionally colliding and creating new pieces of the cosmic puzzle. Here's a thought-provoking detail. Some KBOs exhibit comet-like behavior, developing tails when they venture closer to the sun. These bodies, known as centaurs, are thought to be transitional objects between the Kuiper belt and the inner solar system. It's fascinating to think of them as travelers, journeying from the cold outskirts to the heart of our solar neighborhood. Speaking of travelers, did you know that the New Horizons spacecraft discovered that Pluto has mountains made of water ice? Standing as tall as 3.5 kilometers, these mountains are as remarkable as they are unexpected. In the frigid environment of Pluto, water ice is as hard as rock, sculpting majestic frozen peaks. And here's a captivating thought. Pluto's surface is dotted with features known as bladed terrain. These sharp, knife-like ridges stretch for miles and are thought to be composed of methane ice. Imagine a landscape sculpted by cosmic winds, with features as delicate and ephemeral as frost patterns on a winter window. Let's consider the relationship between Pluto and its surrounding environment. Some scientists hypothesize that Pluto's interaction with the solar wind creates a tail, much like a comet. This invisible wake, composed of escaping atmospheric particles, stretches out into the Kuiper belt, a gentle reminder of Pluto's presence in the vastness of space. Turning our gaze back to the Kuiper belt, did you know that this region is believed to be the source of many short-period comets? These comets, with orbits lasting less than 200 years, are thought to originate from the Kuiper belt before being nudged into the inner solar system. It's a celestial migration, bringing icy visitors into our night skies. Speaking of visitors, the Kuiper belt has played host to countless cosmic wanderers over the millennia. From rogue planets to interstellar objects, the belt's gravitational dance has captured and cast off travelers, shaping its population in ways we are only beginning to understand. As we drift through these icy expanses, consider the discovery of a new class of KBOs known as twartinos. These objects share a 2-to-1 orbital resonance with Neptune, meaning they orbit the Sun twice for every one orbit of Neptune. It's a delicate cosmic choreography, a testament to the intricate gravitational symphony of the solar system. Finally, let your mind wander to the idea that the Kuiper belt holds clues to the existence of more than one undiscovered planet. Some astronomers suggest that the unusual orbits of certain KBOs could point to the gravitational influence of additional, unseen worlds. It's a tantalizing possibility, a cosmic puzzle waiting to be solved. As you reflect on these facts, allow your imagination to drift through the vast and mysterious reaches of the Kuiper belt and Pluto, where each icy body holds stories of creation, change, and the boundless wonders of the universe. Let me take you on a gentle journey further into the mysteries of Pluto and the Kuiper belt. Imagine, if you will, a region so vast that it contains countless worlds, each with its own secrets and stories. This remote area of our solar system, located beyond the orbit of Neptune, is more than just a collection of icy bodies. It's a treasure trove of cosmic wonders. Did you know that despite its distance from the Sun, Pluto experiences weather? Although it may not be the kind of weather we're accustomed to on Earth, Pluto's tenuous atmosphere undergoes changes as it orbits the Sun. Winds can stir the surface, redistributing particles and subtly altering the landscape. Picture a delicate dance of icy particles shaped by invisible currents in the thin air. Speaking of the unseen, Pluto's surface harbors vast plains known as Sputnik Planitia. This heart-shaped region is intriguingly smooth, and scientists believe it is relatively young in geological terms. It's thought to be composed mainly of nitrogen ice, which slowly flows like glaciers do here on Earth. Imagine an icy heart beating slowly over millions of years, a reminder of the dynamic processes at work even in the coldest corners of the solar system. Have you ever wondered about the sounds of space? While the vacuum of space is silent, the data collected by spacecraft can reveal intriguing audio-like signals. For instance, when New Horizons flew past Pluto, it captured interactions between the solar wind and Pluto's atmosphere. These interactions have been converted into sounds that give us a unique glimpse into the otherwise silent realm. Now, consider the phenomenon of cryovolcanism. While volcanoes are typically associated with molten lava, on Pluto they might involve icy materials instead. Cryovolcanoes could spew a slushy mix of water, ammonia, and other volatiles. It's a fascinating concept. Volcanic activity in a realm where ice behaves like molten rock. And here's something that might surprise you. Pluto's surface is dotted with what appear to be massive pits. These features, known as pitted terranes, are thought to form from the sublimation of ices, where solid ice changes directly into gas. Imagine the slow retreat of ice, leaving behind curious depressions that tell of a planet constantly reshaping itself. Let's move beyond Pluto for a moment and explore the intriguing orbits of some Kuiper belt objects. Did you know that there are objects with highly elliptical orbits that take them far beyond the typical confines of the Kuiper belt? These unusual paths suggest they may have been gravitationally influenced by unseen forces, possibly even additional planets lurking in the distant darkness. Are you familiar with the term cold classicals? These are a special group of Kuiper belt objects that have orbits with low inclinations and eccentricities, suggesting they have remained largely undisturbed since the solar system's formation. Imagine these objects as cosmic relics, frozen in time, providing a window into the early solar system. Have you ever heard of the dwarf planet Eris? It's one of the most massive known objects in the Kuiper belt, even more so than Pluto. Its discovery prompted the reclassification of Pluto as a dwarf planet. Eris is covered with a reflective layer of methane ice, which gives it a bright surface. In a way, it's like a distant beacon, a reminder of the many wonders yet to be fully understood. Speaking of reflections, did you know that the albedo, or reflectivity, of objects in the Kuiper belt varies greatly? Some are as dark as coal, while others are as bright as snow. These differences in brightness can tell us about their composition and history, offering clues about the environment in which they formed. Let's pause to consider the mysterious Xena, now known as Eris, which sparked a debate about what constitutes a planet. Its discovery challenged our understanding and led to a broader discussion about the nature of celestial bodies in our solar neighborhood. It's a testament to how new findings can shift our perspective and inspire curiosity. And here's a curious fact. The Kuiper belt is home to a peculiar group of objects known as detached objects. These bodies have orbits that are not significantly influenced by Neptune, suggesting that other forces may have shaped their paths. Their existence hints at the complex gravitational interactions that sculpt the outer solar system. Turning back to Pluto, did you know that its orbital path is tilted relative to the plane of the solar system? This inclination results in dramatic variations in sunlight on its surface during its long journey around the Sun. It's as if Pluto dances to its own rhythm, a celestial wanderer charting a unique course through the heavens. Imagine, if you can, the possibility of liquid water oceans beneath the icy surfaces of some Kuiper belt objects. Although the idea is speculative, it's fascinating to think that even in these frigid realms, where the temperature plummets to depths unimaginable, there might be reservoirs of liquid water hidden beneath layers of ice. As we drift through these thoughts, keep in mind that the Kuiper belt and its countless inhabitants continue to reveal their secrets. Each discovery adds a new piece to the puzzle, inviting us to ponder the vast and intricate tapestry of our solar system. Let your imagination wander through this icy frontier, where the boundaries between known and unknown blur, and the wonders of the cosmos await. Speaking of mysteries, Pluto's atmosphere is a fascinating subject all on its own. Did you know that it expands and contracts as it orbits the Sun? When Pluto is closer to the Sun, its atmosphere thickens, likely due to the sublimation of surface ices. As it moves further away, the atmosphere can freeze and fall back to the surface. Imagine a world where the very air you breathe ebbs and flows with the seasons, a rhythmic dance of molecules responding to the distant Sun. Here's something you might find intriguing. Pluto has 5 known moons, with Charon being the largest and most notable. Charon is so large, in fact, that it doesn't merely orbit Pluto. Rather, the two bodies orbit a common center of gravity that lies outside of Pluto itself. It's a cosmic ballet, a duet between planet and moon, locked in an eternal embrace. The remaining moons, Nix, Hydra, Kerberos, and Styx, are much smaller and have irregular shapes, each adding to the complexity of this distant system. Have you ever pondered what it would be like to stand on Pluto's surface? Imagine gazing up at the sky and seeing Charon looming large, a constant companion in the icy expanse. The sunlight would be dim, much weaker than what we experience here on Earth, giving the landscape an otherworldly twilight glow. It's a place where the ordinary rules of daylight and darkness blur into something entirely unique. Speaking of unique, the Kuiper belt itself is a treasure trove of diversity. Among its myriad objects are binaries, pairs of bodies that orbit each other closely. These binary systems are quite common in the Kuiper belt and provide valuable insights into the processes of planetary formation. By studying them, scientists hope to understand more about the early solar system and how the planets came to be. Now, let's consider the curious phenomenon of resonance. Some Kuiper belt objects are in what's called a resonant orbit with Neptune, meaning that their orbital periods form a simple ratio with that of Neptune. For example, Pluto is in a 3:2 resonance with Neptune, completing 2 orbits around the Sun for every 3 of Neptune. This gravitational dance helps stabilize Pluto's orbit, preventing close encounters with the giant planet. Did you know that the temperature on Pluto can drop to nearly -230 degrees Celsius? It's hard to fathom such cold, where everything is frozen solid and the laws of physics take on a chilling twist. Yet even in these extreme conditions, Pluto's surface is far from static. The interplay of sunlight, geology, and volatile ices ensures that change, however slow, is a perpetual certainty. Imagine for a moment that you're a spacecraft approaching Pluto. As you draw nearer, you'd notice the stark contrast between its bright and dark regions. This variegation is due to differing compositions and geological activity, with some areas being covered in methane and nitrogen ices, while others are coated in a dark, carbon-rich material known as tholin. These tholins are the result of complex chemical reactions in the atmosphere, offering clues about the intricate chemistry at play on this distant world. And speaking of chemistry, did you know that organic compounds have been detected on Pluto's surface? These are complex molecules that contain carbon, and their presence hints at the intriguing possibility of prebiotic chemistry occurring in the Kuiper belt. While there's no evidence of life, the existence of these compounds suggests that the building blocks of life might be more widespread in the universe than we once thought. Pluto's journey around the Sun takes 248 Earth years to complete. That's more than 2 human lifetimes for a single year on Pluto. This slow, deliberate orbit means that seasons on Pluto last for decades, creating a world where time stretches out and change is measured in generations. It's a reminder of the vastness of time and space, and of the patience required to unlock the secrets of distant worlds. The Kuiper belt itself is a region shrouded in mystery. It's believed to contain remnants from the early solar system, icy bodies that never coalesced into planets. These relics, scattered across billions of kilometers, offer a glimpse into the conditions that existed over 4 billion years ago. By studying them, we can piece together the story of how our solar system came to be, an ancient tale written in ice and rock. And here's a curious thought. Some theories suggest that the Kuiper belt might contain undiscovered dwarf planets. With advances in technology and telescopes, astronomers are always on the lookout for new members of this distant family. Each discovery adds a new chapter to the story of the Kuiper belt, expanding our understanding of the solar system's outer reaches. Imagine, if you will, a journey out to the edge of the solar system, to a place where the sun is just a bright star in a velvety black sky. It's a region where time seems to stand still, where the ordinary becomes extraordinary, and where every icy body holds secrets waiting to be uncovered. In this vast expanse, the boundaries of what we know are constantly being challenged, inviting us to dream of the discoveries yet to come. Let me transport you just for a moment to a fascinating celestial phenomenon involving Pluto and its moons. Did you know that Charon, its largest moon, is so tightly bound to Pluto that they are mutually tidally locked? This means that one side of Pluto always faces Charon, and one side of Charon always faces Pluto. Imagine standing on the surface of Pluto and looking up to see Charon perpetually hovering in the same spot in the sky. It's a cosmic dance frozen in place, like a photograph of an endless waltz. While we often think of Pluto as a solitary member of the solar system, it's part of a larger, lesser-known family. You might find it intriguing that Pluto is considered the king of a special group of Kuiper belt objects known as Plutinos. These objects share the same 3:2 orbital resonance with Neptune as Pluto does. It's as if they are all marching to the same cosmic rhythm, keeping time with a distant giant, their paths interwoven by gravity's invisible threads. Speaking of cosmic rhythms, have you ever considered how Pluto's heart-shaped region, known as Tombor Regio, came to be? This icy heart, named after the discoverer of Pluto, Clyde Tombaugh, is actually a vast plain of nitrogen ice. The heart's left lobe, known as Sputnik Planitia, is a basin that may have formed from an impact event. This vast depression is filled with nitrogen ice that undergoes convection, creating the appearance of cells and polygons, as if the surface itself is breathing in slow, geological breaths. Here's something that might surprise you. Beneath Pluto's icy surface, there could be a hidden ocean. Yes, some scientists theorize that a subsurface ocean of liquid water exists, kept warm by the heat from radioactive decay deep within Pluto's core. This potential ocean is a tantalizing thought, as it suggests that even in the coldest reaches of the solar system, warmth and change can find a way. Now, let's turn our gaze again toward the Kuiper belt. This distant region is not just a collection of cold, frozen rocks. It's a dynamic area of the solar system. Did you know that some objects in the Kuiper belt have faint atmospheres? When these icy bodies come closer to the sun, the heat causes sublimation, where solid ice directly turns into gas. This thin, temporary atmosphere creates a fleeting, ghostly veil around these objects as they make their slow journey around the sun. Fascinatingly, the Kuiper belt is home to some of the solar system's most irregularly shaped bodies. Unlike the well-rounded planets, these objects often resemble flattened spheres or even more peculiar shapes. This irregularity is caused by their relatively small size and the lack of enough gravity to pull them into a spherical shape. Imagine the variety of silhouettes that might be cast by these uneven surfaces under the distant sun's light. Have you ever pondered the sheer scale of the Kuiper belt? It's estimated to contain hundreds of thousands of icy bodies, with some scientists suggesting the number could be as high as 300,000 or more. This vast population makes it a treasure trove for astronomers, each object a potential key to unlocking the secrets of the early solar system. Among these intriguing objects, you'll find Haumea, a dwarf planet known for its rapid rotation. It spins so quickly, completing a rotation in just under 4 Earth hours, that it has been stretched into an elongated shape resembling a rugby ball rather than a sphere. This rapid spin might have been caused by a massive collision, an event that left Haumea with its unique form and a pair of small moons. Speaking of moons, did you know that some Kuiper belt objects are known to have numerous moons, much like Pluto? The dwarf planet Eris, for instance, has a moon named Dysnomia. This pairing is another example of how common these moon systems are in the outer solar system, each one a small-scale version of the planet-moon systems we see closer to the Sun. Let me share another curious fact. The Kuiper belt is not just a place of scientific interest, but also one of cultural fascination. In recent years, the exploration of this region has inspired countless stories and works of art that imagine what life might be like on these distant worlds. It's a testament to the enduring human spirit, always looking outward, always wondering what lies beyond the next horizon. Lastly, consider this. The journey of exploration doesn't end with Pluto or even the Kuiper belt. Beyond this icy frontier lies the scattered disk, a region of space where objects have more elliptical and inclined orbits. It's here that some of the most distant known objects in the solar system reside, including Eris, which in some ways rivals Pluto in size. This region, like the Kuiper belt, remains largely unexplored, a reminder that even in our own cosmic backyard, there are still many mysteries waiting to be uncovered. As you drift off to sleep, Let your mind wander to these distant realms, where the quiet dance of celestial bodies continues unabated, a serene ballet played out over billions of years. The universe is vast, and yet, in its vastness, every object, every orbit, is a testament to the wondrous complexity of the cosmos. The beauty of the Kuiper belt lies not just in its vastness but in the secrets it holds about our solar system's formation. Did you know that scientists believe the Kuiper belt is a remnant from that early time, over 4 billion years ago? It's like a cosmic time capsule preserving materials from the solar system's birth. Imagine the stories these icy bodies could tell if they could speak. Speaking of ancient remnants, you might be surprised to learn that Pluto's atmosphere is constantly changing. This thin, tenuous layer of gas is primarily made up of nitrogen, with traces of methane and carbon monoxide. What's fascinating is that as Pluto moves farther from the Sun, its atmosphere begins to freeze and fall to the surface as snow. Can you imagine snowflakes made of nitrogen gently settling on Pluto's terrain? And here's a curious thought. Pluto's orbit is unlike any other planet's. It takes 248 Earth years to complete one journey around the Sun, and its orbit is so elliptical that there are times when Pluto is closer to the Sun than Neptune. This means that for about 10 to 20 years of its orbit, Pluto is actually the 8th planet from the Sun, not the 9th. Pluto's orbit also has another intriguing aspect. It is tilted at a 17-degree angle to the plane of the solar system. This unusual tilt means that sometimes, when observing from Earth, we see its poles rather than its equator. Imagine looking at Earth from above the North Pole. It gives you a completely different perspective, doesn't it? Let's delve into the companions of Pluto. While we often think of Pluto as a solitary wanderer, it actually has a complex family. Charon, its largest moon, is so big compared to Pluto that they don't revolve around Pluto, but rather both revolve around a common center of mass that lies above Pluto's surface. This makes them a double dwarf planet system, a unique feature in our solar system. Charon itself is a world of wonder. Did you know it has a reddish polar region? This intriguing hue is thought to come from tholins, organic molecules created when methane and nitrogen are broken down by ultraviolet sunlight. These tholins could drift from Pluto's atmosphere and settle on Charon, painting its poles with a reddish tint. It's like a cosmic artist has been at work, using the universe as their canvas. Speaking of colors, Pluto is a surprisingly colorful world. Its surface is covered with a variety of hues, from deep reddish browns to pale yellows. These colors are due to the different ices and tholins that cover its surface, each reflecting sunlight in its own unique way. Imagine the subtle shifts in color as the sunlight changes throughout Pluto's long day. And have you ever considered the role of the Sun in this distant region? While the Sun is a distant star from Pluto, it still influences the Kuiper belt's behavior. When these icy objects venture closer to the Sun, even the faint warmth can cause significant changes, like the sublimation of ices and the formation of temporary atmospheres. It's a gentle reminder of the Sun's far-reaching influence, even at the edges of our solar system. The Kuiper belt also offers a fascinating glimpse into the variety of objects that exist beyond the planets. Take Makemake, another dwarf planet in this region. It was named after a deity from Easter Island mythology and is known for its bright surface, which is covered in methane ice. This makes it one of the brighter objects in the Kuiper belt, reflecting much of the sunlight that reaches it. And then there's Sedna, a mysterious object with an extremely elongated orbit that takes over 11,000 years to complete one circuit around the Sun. Its discovery has led to tantalizing questions about the outer reaches of our solar system and what else might be lurking in the vast stretches of space beyond the Kuiper belt. The Kuiper belt's vastness is not just in its distance from the Sun, but in its breadth, spanning a region from about 30 to 50 astronomical units from the Sun. To put it in perspective, that's 30 to 50 times the distance from the Earth to the Sun. Within this vast expanse, the Kuiper belt is believed to be the source of many short-period comets, objects that occasionally make their way into the inner solar system, offering us spectacular night sky displays. Finally, consider the New Horizons mission, a testament to human curiosity and the drive to explore. When it flew past Pluto in 2015, New Horizons provided us with the first close-up images of this distant world, transforming Pluto from a distant point of light into a real tangible place with mountains, valleys, and a heart-shaped glacier. As you close your eyes tonight, imagine the vastness of space and the small spacecraft continuing its journey through the Kuiper belt, still sending back data and expanding our understanding of these distant places. The universe is endlessly fascinating, and even as we drift to sleep, its mysteries continue to unfold. Imagine drifting through the vastness of space, surrounded by the mysteries of the Kuiper belt. Have you ever wondered about the size of Pluto compared to Earth? Surprisingly, Pluto's diameter is just about 2,300 kilometers, making it less than 1/5 the size of Earth. It's even smaller than Earth's moon, yet it holds an entire realm of secrets waiting to be unlocked. Let's ponder for a moment on Pluto's day. Did you know that a single day on Pluto, from one sunrise to the next, lasts about 153 Earth hours? That's more than 6 Earth days for the Sun to cross the sky. Imagine how long a workday or a holiday would feel there. You might find it fascinating that Pluto's surface is composed of more than just rock and ice. Pluto is home to towering mountains that reach up to 3.5 kilometers high, and these are not made from rock, but rather from water ice. On Pluto, water ice is as strong as rock is on Earth. Speaking of Pluto's features, its heart-shaped region, informally known as Tombaugh Regio, is made largely of nitrogen ice and is constantly being reshaped by processes like sublimation. This makes it a dynamic part of Pluto's surface, always changing with the subtle shifts in temperature and sunlight. Have you ever considered the color of the sky on Pluto? While the sky on Earth is a brilliant blue, Pluto's sky takes on a more muted hue, a pale blue, due to the sunlight scattering off tiny particles in its thin atmosphere. Imagine gazing up at this delicate sky, a serene companion to the icy landscape below. And while we're exploring Pluto's sky, let's talk about sunsets. On Pluto, the Sun is about 1,000 times dimmer than what we see on Earth. As it sets, the thin atmosphere scatters sunlight in a way that might cast a unique glow across the icy surface. Picture a soft, lingering twilight stretching into the long Plutonian night. Venturing further into the Kuiper belt, you'll find a multitude of icy bodies. But did you know that it's estimated to contain over 100,000 objects that are at least 100 kilometers in diameter? That's a bustling neighborhood by any standard, with each object potentially harboring its own set of surprises. Consider Haumea, another intriguing dwarf planet within the Kuiper belt. It's shaped like a squashed egg due to its rapid rotation, completing one full spin in under 4 hours. This swift rotation is thought to have stretched Haumea into its unusual shape, unlike anything in our inner solar system. Reflect on the idea of moons in this distant region. Quaoar, a large Kuiper belt object, has its own moon named Waywat. This moon is about 1/8 the size of Quaoar, and its presence helps scientists learn more about the mass and density of its parent body. Even at these great distances, celestial partnerships are not uncommon. The Kuiper belt also challenges our understanding of planetary formation. Its diverse collection of bodies, ranging from small icy rocks to larger dwarf planets, provides clues about the solar system's early days. These clues suggest that the formation of the planets was a more chaotic process than previously thought, with many objects colliding and merging over time. One might also consider the temperature in the Kuiper belt. Imagine an environment where the average temperature hovers around -230 degrees Celsius. This extreme cold preserves the ices on these distant objects, slowing chemical reactions to a crawl and keeping their surfaces largely unchanged over billions of years. It's intriguing to note that some Kuiper belt objects, like Eris, are actually more massive than Pluto, despite their smaller size. Eris, another dwarf planet, has a surface covered in a reflective layer of methane ice, which gives it a bright sheen, making it one of the most luminous objects in the Kuiper belt. Speaking of brightness, some of these distant objects have albedos, the measure of how much sunlight they reflect, that are surprisingly high. For instance, Makemake reflects over 60% of the sunlight that reaches it, making it one of the brighter sights in the Kuiper belt. Imagine the glinting surfaces of these icy worlds, sparkling like distant stars. And here's a captivating thought. The Kuiper belt is believed to be a source of short-period comets. These comets are thought to originate from this distant region and occasionally make their way into the inner solar system, offering us a glimpse into the outer reaches from which they hail. Finally, as we ponder the Kuiper belt, it's humbling to remember that we've only just begun to explore it. Missions like New Horizons provide invaluable insights, but the vast majority of this distant region remains a mystery. As you drift toward sleep, imagine the quiet exploration continuing, each discovery a small step toward unraveling the mysteries of these distant worlds. Let me share something intriguing about Pluto's atmosphere. It's incredibly thin compared to Earth's, primarily composed of nitrogen with traces of methane and carbon monoxide. What's fascinating is that this fragile blanket of gases expands and contracts as Pluto moves closer to or further from the Sun in its elliptical orbit. Imagine an atmosphere that breathes with the seasons, swelling as the dwarf planet warms and shrinking as it cools. Speaking of surprising movements, Pluto's orbit itself is a bit of a marvel. Unlike the near-circular orbits of the planets in our solar system, Pluto's orbit is more elliptical and even inclined, tilted by about 17 degrees from the plane of the solar system. This unique path sometimes brings Pluto closer to the Sun than Neptune, creating a brief period when it's not the most distant planet from the Sun. Can you picture a world where this distant traveler occasionally crosses paths with the giant planets, like a cosmic dance? And here's something curious about Pluto's status as a dwarf planet. When it was first discovered in 1930, it was classified as the 9th planet of our solar system. However, in 2006, the International Astronomical Union redefined what it means to be a planet, leading to Pluto's reclassification as a dwarf planet. This change sparked much debate and emotion, illustrating how our understanding of the cosmos evolves over time. Now, let's consider the weather on Pluto. While we might expect such a distant world to be entirely static and frozen, Pluto experiences subtle but significant changes. Observations have shown that its surface pressure can vary greatly, suggesting seasonal weather patterns driven by its long, 248-year orbit, imagine the patience required to observe a single season unfold over decades. Contemplating the moons of Pluto, Charon is the largest and most well-known, but did you know that Pluto has 4 other, much smaller moons named Styx, Nix, Kerberos, and Hydra? These moons likely formed from a massive collision in the distant past, similar to the theory of how Earth's moon formed. This celestial family provides a window into Pluto's tumultuous history, each moon a fragment of its ancient past. And here's a captivating detail about Charon. Its size relative to Pluto is quite substantial, about half the diameter of Pluto itself. This makes the Pluto-Charon system more akin to a binary dwarf planet system, where both bodies orbit a common center of gravity that lies outside of Pluto. It's a celestial relationship that's as unique as it is fascinating, a cosmic partnership spinning in the depths of space. Speaking of otherworldly features, Pluto's surface is dotted with regions of varying colors, from the dark, reddish-brown of Cthulhu Macula to the bright and icy expanse of Sputnik Planitia. These color variations are caused by complex organic molecules known as tholins, which form when methane and other gases are exposed to sunlight. Imagine a surface painted by the sun itself, slowly crafting a masterpiece over eons. In the broader Kuiper belt, there's an object known as Arrokoth, which was explored by the New Horizons spacecraft. Arrokoth is particularly unusual due to its appearance: 2 lobes that seem to have gently collided and stuck together. This makes it a contact binary, offering a glimpse into the gentle processes that might have formed planetesimals in the early solar system. Imagine 2 snowballs in space, gently touching and becoming one. Reflecting on the vastness of the Kuiper belt, it serves as a boundary of sorts for our solar system, marking the edge of the region where the sun's influence is dominant. Beyond it lies the Oort cloud, a hypothetical shell of icy bodies thought to be even more distant and mysterious. The Kuiper belt, however, remains more accessible, a frontier on the outskirts of our known solar system, inviting us to explore further. And if you're wondering about the potential for more discoveries, the Kuiper belt is brimming with possibilities. Scientists estimate there could be as many as 70,000 objects larger than 100 kilometers in diameter, and we've only charted a fraction of them. Each new discovery adds another piece to the puzzle of our solar system's formation and evolution. In considering the distant reaches of Pluto and the Kuiper belt, it's humbling to think about how much we've learned in recent decades. With missions like New Horizons, we've begun to pull back the veil on these mysterious worlds, illuminating them for the first time. But there is still so much to uncover, each new piece of data leading us deeper into the unknown. So, as you drift into slumber, let your thoughts wander through this remote region of space. Envision the uncharted worlds waiting patiently for our curious eyes, each one holding secrets as old as the solar system itself. The whispers of distant celestial bodies offer gentle reminders of the infinite wonders that lie beyond, calling softly through the silence of the night. Let me share a curious aspect about Pluto's heart-shaped region known as Tombaugh Regio. Named after Clyde Tombaugh, the astronomer who discovered Pluto, this region isn't just a charming feature, it's made primarily of nitrogen ice. Surprisingly, this heart-shaped expanse acts like a weather system, circulating and recycling gases within Pluto's thin atmosphere. Picture a heart that beats not with blood, but with frozen nitrogen, sculpting the landscape as it moves. Did you know that Pluto has glaciers? These glaciers, primarily composed of nitrogen ice, slowly creep across the dwarf planet's surface, much like glaciers on Earth. However, unlike our glaciers, these icy flows occur at temperatures far below what we experience here. Imagine the silent, slow movement of ice across a distant world, a testament to the dynamic processes that can occur even at the edge of our solar system. Here's an intriguing thought. The Kuiper belt is not just a collection of icy bodies, but a treasure trove of primordial material. These objects have remained largely unchanged since the solar system's formation over 4 billion years ago. In many ways, they are like time capsules, preserving the conditions of the early solar system. Imagine holding a piece of history that stretches back to the dawn of our cosmic neighborhood. Speaking of distant histories, one of Pluto's lesser-known features is the presence of cryovolcanoes. Unlike the fiery volcanoes on Earth, cryovolcanoes erupt with a mixture of water, ammonia, or methane, rather than molten rock. These icy volcanoes provide a glimpse into the underground reservoirs that may exist beneath Pluto's surface. Picture icy geysers spewing their contents into the frigid sky, reshaping the landscape in a cold but no less dramatic fashion. And here's something that might surprise you. Despite its distance from the Sun, Pluto experiences sunsets just like Earth, casting the landscape in warm hues. The Sun may be tiny and faint from Pluto's vantage point, but when it dips below the horizon, the atmosphere scatters the light, creating a twilight glow. Envision standing on Pluto watching the dim sunset, wrapping the icy world in a gentle otherworldly dusk. Now consider this, the New Horizons mission, which gave us our first close-up views of Pluto, took 9.5 years to reach the dwarf planet, covering over 5 billion kilometers. It highlighted the vast distances within our solar system and the incredible patience required to explore them. This journey reminds us of the dedication needed to reach beyond our immediate cosmic neighborhood. Did you ever wonder how Pluto's moons might affect its surface? With Charon being so close and relatively large, tidal forces between the two bodies likely play a role in shaping their surfaces. The gravitational pull from Charon could be responsible for some of the geological features observed on Pluto, hinting at a dynamic interaction over time. Imagine the gentle tug and pull between these celestial partners, influencing the very crust of Pluto itself. Let's ponder the fact that in the Kuiper belt, some objects follow strange, elongated orbits that suggest the influence of unseen forces. These mysterious trajectories have led scientists to theorize the existence of a yet undiscovered planet, often referred to as Planet 9. The possibility of another world lurking beyond Pluto captures our imagination, reminding us that the cosmos holds many secrets still waiting to be revealed. Here's another fascinating tidbit. Pluto's surface colors and features are not static. Over the years, as Pluto orbits the Sun, changes have been observed in its brightness and color distribution. These variations are likely due to seasonal shifts in its thin atmosphere and surface frost. Picture the subtle changes in a landscape sculpted by light and shadow, a continuously evolving portrait of a world far away. And speaking of distances, consider that the Kuiper belt extends from just beyond Neptune's orbit to about 55 times the distance from the Earth to the Sun. This vast region is home to countless small bodies, each one a potential object of study, offering clues about the building blocks of the solar system. Imagine peering into a cosmic library, each object a book filled with untold stories. Have you ever wondered how scientists can study such distant worlds? The process involves careful observation, often using large telescopes equipped with advanced technology. Through this, Scientists can detect the faint light reflected off these distant objects, allowing them to discern their composition, size, and even weather patterns. It's like deciphering a mystery from the faintest of whispers, a testament to human ingenuity and curiosity. Reflect on this. Although Pluto is no longer classified as a planet, it still holds a special place in our hearts. Its reclassification highlights the ever-evolving nature of science, where discoveries lead to new understandings and sometimes redefinitions. This process, though sometimes controversial, ensures that our knowledge continues to grow and adapt. Finally, let's consider the legacy of exploration. The New Horizons mission not only provided a wealth of data about Pluto and the Kuiper belt, but also inspired a new generation of scientists and dreamers. As we push the boundaries of what we know, we continue to fuel the fire of curiosity that has driven human exploration for centuries. Envision a future where the mysteries of the Kuiper belt are unraveled, each discovery a new chapter in the story of our solar system. As you drift off to sleep, let your mind wander through these distant realms where the familiar meets the unknown and every horizon promises a new adventure. Let me take you on a journey through the frosty expanses of Pluto and the Kuiper belt, where the wonders never cease. Did you know that Pluto is home to some of the most spectacular glaciers in our solar system? Unlike Earth's glaciers, which are primarily composed of water ice, Pluto's are sculpted from solidified nitrogen, slowly meandering across its surface. Imagine a river of nitrogen flowing languidly in the extreme cold. Now, here's a curious detail. Pluto has an atmosphere that expands and contracts in response to its elliptical orbit. When Pluto is closer to the Sun, its ices sublimate, thickening the atmosphere. As it drifts farther away, the atmosphere freezes and falls back to the surface. This dynamic atmospheric cycle is a dance of ice and vapor, influenced by Pluto's distant relationship with the Sun. Speaking of Pluto's orbit, did you know it actually crosses inside the orbit of Neptune for a period of 20 years during its 248-year journey around the Sun? Despite this apparent intersection, Pluto and Neptune will never collide due to a phenomenon known as orbital resonance. Their orbital paths are timed in such a way that they always maintain a safe distance, a celestial choreography that keeps them in harmony. Let's delve deeper into Pluto's complex system of moons. Aside from Charon, Pluto is orbited by 4 smaller moons: Nix, Hydra, Kerberos, and Styx. These moons are thought to have been formed from the debris of a colossal collision, much like our own moon. Imagine the cosmic chaos of such an event, with fragments coalescing over eons into the serene companions we see today. And here's something you might find fascinating. The surface of Pluto is dotted with heart-shaped regions, the most famous being Tombor Regio, named in honor of Clyde Tombor, who discovered Pluto in 1930. This region is largely composed of nitrogen and methane ice. Its bright expanse a striking contrast to the darker regions surrounding it. Imagine the heart of Pluto, a poignant reminder of human curiosity and discovery. In the Kuiper belt, did you know that some of its objects are known as cold classicals? These bodies have remained in nearly the same orbit since the solar system's infancy, untouched by the gravitational pull of the larger planets. Picture them as ancient relics, pristine and unchanged, offering a glimpse into a time long before planets took their current form. Here's a captivating thought. The surface temperature of Pluto can plummet to around -228 degrees Celsius. Yet, despite this frigid climate, Pluto's surface is surprisingly varied, with mountains, valleys, and plains, each telling a story of geological activity that defies the norm for such a distant, icy world. Have you ever considered the role sunlight plays on Pluto? Although the sun appears merely as a bright star from Pluto's vantage point, it is still enough to drive seasonal changes. The tenuous atmosphere, composed mostly of nitrogen, with small amounts of methane and carbon monoxide, undergoes shifts that paint Pluto's surface with different hues over time. It's a testament to the power of sunlight reaching out across billions of kilometers to leave its mark. The Kuiper belt is not just home to icy bodies, but also to dwarf planets, much like Pluto. Eris, another dwarf planet beyond Neptune, is slightly smaller than Pluto, yet more massive. Its discovery was one of the key factors in the debate over Pluto's planetary status, highlighting the rich diversity of celestial bodies that populate this distant region. Did you know that some Kuiper belt objects are in a state of binary dance? These objects, such as Pluto and Charon, orbit around a common center of mass located outside of the larger body. This unique relationship creates a system where both bodies are bound together in a gravitational embrace, a cosmic waltz that captivates astronomers and dreamers alike. And speaking of dreams, consider this: the exploration of Pluto and the Kuiper belt has only just begun. With missions like New Horizons providing a wealth of data, we are beginning to understand the complexity and diversity of this distant frontier. Each discovery adds another piece to the puzzle of our solar system's history, inviting us to ponder what lies beyond the edge of the known world. Reflect on the sheer scale of the Kuiper belt. Stretching for more than 20 astronomical units, it is a vast expanse filled with countless bodies, each one a world unto itself. Among these are some of the most enigmatic objects waiting to be explored by future missions. Imagine the potential for discovery, the thrilling prospect of uncovering secrets that have eluded us for so long. Finally, consider the whispers of potential life that spark imaginations. While Pluto and its neighbors are inhospitable by Earth standards, some scientists speculate that the subsurface oceans, warmed by internal heat, could harbor life. It is a tantalizing thought, providing a hint of possibility that life might find a way even in the most unlikely places. As you let these thoughts carry you into the night, envision the endless possibilities that await us in the shadowy reaches of the Kuiper belt. Each new day brings the promise of fresh discoveries and deeper understanding, a reminder that the universe is as vast as it is wondrous. Let me share something intriguing about Pluto's size. You might be amazed to learn that Pluto is smaller than the Moon orbiting our Earth. With a diameter of about 2,370 kilometers, Pluto is only about 2/3 the size of our Moon. Despite its diminutive stature, Pluto holds a mighty place in our hearts and imaginations. Here's a fascinating thought. Pluto's mass is so slight that its gravitational pull is only about 6% of that on Earth's surface. Can you imagine stepping onto Pluto and feeling almost weightless? This low gravity means that if you were to drop a feather and a rock on Pluto, they would float gently to the ground together, as if in a slow-motion ballet. Speaking of gravity, did you know Pluto's atmosphere extends up to 1,000 kilometers above its surface? That's quite remarkable for such a small celestial body. This tenuous layer, primarily made of nitrogen, is constantly escaping into space, creating a tail much like a comet's. Imagine Pluto trailing a whispery veil as it journeys through the solar system. Let's consider the surface features of Pluto, which are anything but monotonous. A particularly striking feature is Sputnik Planitia, a vast icy plain located within the heart-shaped region of Tombour Regio. This area is geologically young, only about 100 million years old, and is covered with nitrogen ice. Its surface resembles a patchwork quilt of frozen polygons, hinting at underlying convection processes. These patterns are a testament to the dynamic nature of Pluto's geology. Now, imagine looking into the sky from Pluto. Because it is so far from the Sun, sunlight on Pluto is akin to twilight here on Earth. It's a world bathed in a permanent dusk, casting long shadows over its icy landscape. Picture the serene beauty of a sky where the sun is just another bright star, an unassuming presence amidst the cosmic backdrop. Turning our gaze to the Kuiper belt, think about how its objects are remnants from the solar system's formation. These ancient bodies provide a window into the past, much like time capsules preserving the conditions from over 4 billion years ago. They hold the secrets of the building blocks that formed the planets, offering clues to the early solar system's dynamics. Here's something that might surprise you. Some Kuiper belt objects have incredibly elongated orbits. Take Sedna, for example, a distant object whose orbit takes it more than 100 times farther from the Sun than Earth. Its journey around the Sun lasts about 11,000 years, a staggering timescale that stretches our understanding of cosmic time. Reflecting on the diversity of the Kuiper belt, it's intriguing to note that some objects there are unlike any other known celestial bodies. Consider Haumea, a dwarf planet that is shaped like a squashed egg due to its rapid rotation. This fast spin, completing a turn every 4 hours, distorts Haumea into an elongated shape, a unique feature among dwarf planets. And here's a curious fact about Charon, Pluto's largest moon. Evidence suggests that Charon's surface features, such as fractures and ridges, were created as the internal ocean froze and expanded, cracking the crust. Imagine the icy beauty of those frozen seas hidden deep beneath the surface. Speaking of moon mysteries, did you know that Nix and Hydra, two of Pluto's smaller moons, are irregularly shaped and highly reflective? Their surfaces, likely coated with water ice, reflect sunlight like tiny mirrors in space. It's astonishing to think of these moons twinkling in the darkness, like cosmic beacons in Pluto's orbit. As we explore further, consider this. The Kuiper belt is home to some of the most intriguing binaries in our solar system. Binary systems, where two objects orbit each other around a common center, are not uncommon here. These partnerships may hold clues about how such systems formed and evolved. Imagine two icy bodies locked in an eternal dance, their gravitational pull forever binding them together. And here's an interesting hypothesis. Some scientists propose that elusive Planet 9 could be lurking in the distant reaches beyond the Kuiper belt. This hypothetical planet, larger than Earth, is thought to be influencing the orbits of some Kuiper belt objects. The possibility of discovering a new planet adds an element of exciting mystery to our solar exploration. Reflect for a moment on the subtle colors of Pluto's surface. Did you know that tolins, complex organic molecules formed by chemical reactions driven by sunlight, give Pluto its reddish hue? These compounds, scattered across the surface, are the result of sunlight interacting with methane and nitrogen, painting Pluto with soft, earthy tones that are beautiful and subtle. Finally, as the New Horizons mission swept past Pluto in 2015, it captured images that revealed a world far more complex than we ever imagined. Among the findings were towering ice mountains and mysterious flowing ice glaciers. The presence of these features suggests that Pluto is far from a static world. Instead, it is a place of unexpected dynamism and beauty. Each of these revelations about Pluto and the Kuiper belt invites us to see our solar system in a new light. The mysteries and wonders of these distant realms whisper tales of the past, offering us a glimpse into the cosmic dance of creation that continues to unfold even in the farthest reaches of our celestial neighborhood. Let these thoughts guide you into a peaceful slumber, where dreams of icy worlds and distant stars beckon. The mysterious nature of Pluto is as deep as the icy plains that cover its surface. Did you know that Pluto's heart-shaped region, known as Tombaugh Regio, is not only visually striking, but also geologically active? Beneath its frozen exterior lies a layer of nitrogen ice that is constantly in motion. This movement is driven by the slow sublimation of the ice, which means it turns directly into gas, creating a cycle of renewal that keeps the surface fresh and young. Imagine witnessing an ever-changing landscape where the ground beneath you is slowly but steadily reshaping itself. Speaking of dynamic changes, have you ever wondered about the weather conditions on Pluto? The dwarf planet experiences seasons much like Earth, but they are far more extreme and prolonged. Each season lasts for over 20 Earth years due to Pluto's long orbital period around the Sun. The changes are so pronounced that they result in the redistribution of its ice, causing the surface to brighten and darken over time. Can you picture a world where the landscape itself transforms with the seasons? Let me share something intriguing about Pluto's atmosphere. It isn't just a static layer surrounding the planet. Instead, its density and composition change with its distance from the Sun. When Pluto is closer to the Sun, its atmosphere expands and becomes more substantial. Conversely, as it moves away, the atmosphere collapses, freezing onto the surface. This cycle is akin to a breath, with Pluto inhaling and exhaling its atmosphere over its 248-year orbit. Now, here's a curious fact. The icy plains of Pluto are not only captivating, but also host to mysterious dark patches known as tholoi. These patches are circular, and their precise formation is still a puzzle to scientists. Some believe they may be remnants of ancient cryovolcanic activity, or deposits left by explosive geysers of nitrogen. Imagine the silent eruption of icy material painting circular patterns across the landscape. Turning to Pluto's moons, let's consider the intriguing characteristics of its largest moon, Charon. Although it shares a gravitational tug-of-war with Pluto, Charon's surface tells a tale of its own. The towering cliffs and deep canyons suggest that Charon experienced a tectonic upheaval, possibly from the freezing of a once liquid ocean beneath its crust. Imagine standing on Charon and gazing at these towering formations, evidence of a moon undergoing its own geological evolution. It's fascinating to note that Charon is locked in synchronous rotation with Pluto, meaning the same side of Charon always faces Pluto, much like our own moon and Earth. This celestial dance results in the same view of each body from the other's surface, an eternal cosmic embrace that adds to their unique relationship. In the vastness of the Kuiper belt, consider the sheer number of objects scattered across this distant region. Scientists estimate there are more than 100,000 icy bodies larger than 100 kilometers in diameter. These objects form a complex and ever-evolving tapestry, remnants of the primordial disk that encircled the young sun. Picture each object as a piece of a cosmic puzzle, each with its own story to tell about the early solar system. Moving further into the Kuiper belt, let's explore a lesser-known aspect, the presence of small moons orbiting some of its larger bodies. These moons are thought to have formed from debris created by past collisions. Imagine the aftermath of such cosmic collisions, with fragments of rock and ice coalescing over time to form these tiny companions. One particularly intriguing Kuiper belt object is Makemake, a dwarf planet named after the creator god of the Rapa Nui mythology of Easter Island. Makemake is covered in a layer of methane ice, giving it a bright, reflective surface. Observations suggest that its surface may also be dotted with patches of ethane, creating a colorful mottled appearance. Picture a cosmic canvas painted with the hues of methane and ethane, shimmering in the distant sunlight. Let's not forget about Kuiper, another fascinating denizen of the Kuiper belt. This dwarf planet is notable for its large size, nearly half that of Pluto, and its exceptional surface features. Kuiper is covered in crystalline water ice, a clue that suggests cryovolcanism may have once occurred there, reshaping its surface. Imagine ice volcanoes spurting forth material, creating a landscape that glistens in the dim sunlight. And here's an extraordinary detail. Eris, another dwarf planet in the Kuiper belt, is actually slightly more massive than Pluto. Its discovery in 2005 led to the reclassification of Pluto as a dwarf planet. Eris's surface is coated with a layer of frozen methane, giving it a reflective gleam that rivals that of freshly fallen snow. Envision a world where the surface shines like a frost-covered morning, refracting the light of distant stars. Finally, ponder the sheer distances involved in exploring these distant worlds. The New Horizons mission, which provided us with our first close-up images of Pluto, traveled over 4 billion kilometers from Earth. This journey, lasting nearly a decade, underscores the vastness of space and the dedication required to explore its hidden corners. Imagine the patience it takes to await the arrival of a spacecraft at the edge of our solar system, ready to unveil the secrets of worlds we've only dreamed of seeing. As you reflect on these wonders, let the mysteries of the cosmos cradle you into a gentle rest, with dreams filled with icy landscapes and distant twinkling stars. As you let your mind drift through the vast expanse of the Kuiper belt, consider the peculiar case of the dwarf planet Haumea. Did you know that Haumea is shaped more like a rugby ball than a sphere? This elongated shape is the result of its rapid rotation, spinning on its axis every 4 hours. Can you imagine a day flashing by in just a few hours? This rapid spin is not only unique, but also influences Haumea's gravitational pull, affecting the distribution of surface material in fascinating ways. Speaking of unique characteristics, here's something remarkable. Pluto has an atmosphere that extends as far as 16 times its diameter. This tenuous layer is primarily composed of nitrogen, with traces of methane and carbon monoxide. The atmosphere's extent means it stretches thousands of kilometers into space, creating a thin, ghostly veil around the planet. Isn't it intriguing to contemplate an atmosphere that is both extensive yet delicate, whispering through the cosmos? Turning our gaze back toward the Kuiper belt, we encounter the concept of cold classicals. These are objects with nearly circular orbits, remaining largely undisturbed since the solar system's formation. Imagine them as time capsules preserving the conditions of the early solar system. These cold classicals offer us invaluable insights into the primordial materials from which our solar neighborhood was born. Here's another fascinating tidbit. Pluto has 5 known moons, with the largest being Charon. The other 4, Styx, Nix, Kerberos, and Hydra, are much smaller and are thought to have formed from the debris of a massive collision. Each moon follows a unique orbital path, and they interact with each other in a complex gravitational dance. Picture these tiny celestial bodies orbiting in an elaborate waltz, their movements choreographed by the unseen forces of gravity. In the dim, distant reaches of the Kuiper belt, we find the mysterious object known as Sedna. What makes Sedna so extraordinary is its incredibly long orbit, taking around 11,000 years to complete one trip around the Sun. This distant wanderer moves through a region known as the Inner Oort cloud, hinting at a vast, unexplored frontier beyond the Kuiper belt. Sedna's presence inspires a sense of wonder about the hidden realms just beyond our grasp. Now, let me tell you about an intriguing phenomenon known as Pluto's heart. This heart-shaped region, named Tombor Regio after Pluto's discoverer, is a vast expanse of nitrogen ice that spans over 1,000 kilometers. The heart's left lobe, Sputnik Planitia, is a large, icy plain, while the right lobe is a series of rugged, mountainous terrain. Imagine a heart so immense that it defines the landscape of an entire planet, reflecting sunlight in a gentle, frozen embrace. As we glide through the Kuiper belt, consider the surprising fact that many of its objects have unusual colors. Observations reveal hues ranging from red to gray, resulting from complex chemical processes on their icy surfaces. These colors are thought to arise from tholins, organic compounds created by the interaction of sunlight with methane and nitrogen. Picture a world painted with a palette drawn from cosmic chemistry, each shade telling a story of light and shadow. Here's a curious aspect of Pluto's environment. Its surface temperature can plunge to as low as -225 degrees Celsius. This frigid climate allows for the existence of exotic ices, such as frozen methane and nitrogen. Such extreme cold gives rise to a terrain sculpted by the delicate interplay of frost and thaw, creating a landscape that is both alien and eerily beautiful. In the Kuiper belt, there's a concept of binary systems, where two objects of similar size orbit around a common center of mass. Pluto and Charon are the most famous example, but there are many other such pairs scattered throughout the belt. These binary systems provide clues about the processes that shaped the early solar system, and studying them helps unravel the mysteries of how planets and moons come to be. Now, did you ever wonder what it would be like to stand on Pluto during its long twilight? The Sun, seen from Pluto, appears as a bright star in the sky, providing a gentle glow rather than the intense warmth we experience on Earth. This dim light casts long, soft shadows over the icy plains and mountains, creating an otherworldly scene that feels both peaceful and profound. One last delightful fact to ponder. Despite its classification as a dwarf planet, Pluto has weather patterns and geological activity that rival those of larger planets. Winds sweep across its surface, carrying nitrogen haze that settles in intricate patterns. Cryovolcanoes may still be active, hinting at a dynamic interior. Imagine a world where even in the cold, remote reaches of space, change is constant and vibrant. As you continue to reflect on these distant worlds and their secrets, let the tranquility of the cosmos enfold you. Picture the endless expanse of stars, each a bright promise of more mysteries to discover. And as you drift into slumber, may your dreams be filled with the serene beauty of the Kuiper belt and the enigmatic charm of Pluto. Imagine, if you will, a place where the sun is but a distant gleam, casting its light over ancient, icy landscapes. Pluto, despite its diminutive size, harbors secrets that surprise even the most seasoned explorers of our solar system. Let me share something fascinating with you. Pluto's orbit is quite eccentric, meaning it doesn't follow a perfect circle around the Sun. Instead, it takes an oval path that sometimes brings it closer to the Sun than Neptune. Isn't it intriguing to consider a world that, on occasion, slips inside the orbit of a neighboring planet? Speaking of orbits, here's something curious. While Pluto takes 248 years to complete its journey around the Sun, Charon orbits Pluto in just 6.5 days. This rapid orbit means that one side of Charon always faces Pluto, much like our Moon, with Earth. It's as if they're engaged in an endless celestial embrace, tethered by gravity. Now, let's ponder the remarkable detail that the surface of Pluto has vast regions of stark contrast. The icy plains of Sputnik Planitia rest beside dark, craggy mountains made of water ice, towering as high as 3,000 meters. Water ice, as hard as rock under Pluto's frigid conditions, creating a dramatic and breathtaking landscape. Here's another surprising aspect. Pluto's atmosphere undergoes a fascinating cycle. During its closest approach to the Sun, the increased warmth causes the nitrogen ice on Pluto's surface to sublimate, forming a transient atmosphere. As Pluto moves away from the Sun, this atmosphere freezes and falls back to the surface. It's a rare celestial symphony where climate and orbit dance in perfect harmony. Have you ever wondered what the sky looks like from the surface of Pluto? The atmosphere scatters sunlight, giving the sky a blue tint, much like the skies here on Earth. This hue, set against the backdrop of space, offers a serene, familiar beauty in an otherwise alien world. Can you picture standing on Pluto and gazing up at that tranquil azure sky? Moving beyond Pluto, the Kuiper belt reveals its own surprises. Consider the object known as Quaoar, one of the larger bodies in the belt. Quaoar is about half the size of Pluto and even boasts its own moon, Waywatt. The existence of such moons around these distant objects hints at the complex gravitational interactions that occur even on the solar system's fringe. Here's a thought-provoking fact. The Kuiper belt is home to some of the oldest objects in the solar system. These icy bodies have remained largely unchanged for over 4 billion years, offering a glimpse into the conditions that existed during the solar system's infancy. Each one is like a time capsule, preserving the whispers of creation within its frozen heart. Among these ancient objects, Makemake stands out for its unique reddish hue and the presence of methane ice on its surface. This methane, altered by sunlight, gives Makemake a distinctive color, providing clues to its composition and the processes at work in the Kuiper belt. Imagine a world painted by the universe's gentle hand, each stroke telling a story millions of years old. Did you know that there are many more dwarf planets awaiting discovery in the Kuiper belt? With advancements in technology, astronomers estimate that there could be hundreds or even thousands of such bodies yet to be found. Each new discovery adds a piece to the puzzle of how our solar system evolved, expanding our understanding of the cosmos. Speaking of discoveries, Eris is another intriguing dwarf planet in the Kuiper belt. Once thought to be larger than Pluto, Eris played a key role in the debate that led to the reclassification of Pluto as a dwarf planet. Eris, with its highly reflective surface, shines brightly in our telescopes, challenging our notions of what constitutes a planet. Now, imagine the possibility of subterranean oceans on these distant worlds. Some scientists speculate that beneath the icy crust of Pluto or other Kuiper belt objects, liquid water might exist, kept warm by the residual heat of the planet's core. These hidden oceans spark the imagination, hinting at the potential for life in unexpected places. Here's a delightful fact. Pluto has what is known as bladed terrain. This striking geological feature consists of razor-sharp ridges of methane ice, standing tall across its surface. These blades, likely formed by the slow erosion of methane ice, create a surreal and otherworldly landscape that feels both remote and mysteriously inviting. And in the vastness of the Kuiper belt, there's a phenomenon known as a scattered disk. Objects within this disk have highly eccentric orbits, thought to be the result of gravitational interactions with Neptune long ago. These scattered objects, like cosmic nomads, continue to drift through space, reminding us of the dynamic forces that have shaped our solar system. Finally, consider the sheer scale of the Kuiper belt itself. Extending from just beyond the orbit of Neptune to over 50 astronomical units from the Sun, it encompasses an expanse of space filled with the echoes of our solar system's birth. It's humbling to think about the countless objects dwelling in this distant region, each with its own story, waiting patiently for us to uncover. As you let these thoughts dance softly in your mind, consider the majesty of the universe that stretches far beyond our sight. In the quiet embrace of night, may the mysteries of Pluto and the Kuiper belt fill your dreams with wonder and possibility, guiding you gently into a peaceful slumber. Let me share something interesting with you. Pluto has a heart. Well, not literally, but its most famous geological feature is a large heart-shaped region known as Tombaugh Regio. This vast plain of nitrogen ice is a standout feature captured by the New Horizons spacecraft and has captivated astronomers and the public alike. It's a reminder of how these distant worlds can spark curiosity and affection in us earthbound observers. Did you know that Pluto's orbit is quite unusual compared to the planets in our solar system? Unlike the almost circular orbits of the planets, Pluto's path around the Sun is highly elliptical and tilted. This means that for a portion of its orbit, Pluto actually comes closer to the Sun than Neptune, creating a celestial dance that is both intricate and captivating. Speaking of orbits, the Kuiper belt itself is structured in a fascinating way. It's not just a random scattering of icy bodies. Rather, it contains dynamically distinct populations. There are classical Kuiper belt objects with relatively stable orbits, and then there are resonant objects like Pluto, which are locked in a gravitational dance with Neptune. These resonant objects have orbits that resonate with Neptune's, showcasing the invisible threads of gravity that weave through our solar system. Here's a thought-provoking fact. Pluto experiences seasons, just like Earth. However, because it takes Pluto almost 248 years to complete one orbit around the Sun, each season lasts over 60 years. Imagine a summer or winter that spans generations, with the landscape slowly shifting under the influence of the distant Sun. Can you imagine that the Kuiper belt might have once been more than twice its current size? It's believed that a significant amount of material in the Kuiper belt was ejected by gravitational interactions with the giant planets, particularly Neptune. This scattering event helped shape the current architecture of our solar system, demonstrating the dynamic history that lies hidden in the dark reaches beyond the known planets. Here's something else to ponder: the concept of a third zone of the solar system. With the discovery of the Kuiper belt, astronomers realized that our solar system is divided into three zones: the inner rocky planets, the middle gas giants, and the outer icy bodies of the Kuiper belt. This division helps us understand the solar system's formation and the different environments that exist within it. Have you ever heard of Haumea? This dwarf planet in the Kuiper belt has an elongated shape which is believed to be the result of its rapid rotation. Haumea spins on its axis once every 4 hours, one of the fastest rotation rates of any large object in the solar system. This rapid spin has stretched Haumea into a football-like shape, a testament to the diverse characteristics of these distant objects. Here's something fascinating. Some Kuiper belt objects, including Pluto, have been found to have their own ring systems. This was a surprising discovery, as rings were previously thought to be a feature exclusive to the giant planets. These rings challenge our understanding and suggest that small bodies might have more complex histories than we previously imagined. Did you know that there are objects in the Kuiper belt, known as cold classicals? These are bodies that have remained relatively undisturbed since the solar system's formation. Their stable circular orbits provide a pristine record of conditions in the early solar system, unaltered by the gravitational influences of the giant planets. Here's a surprising twist. The Kuiper belt might hold the key to understanding the mysterious Planet 9. Some astronomers propose that an unseen, massive planet could exist far beyond Neptune, influencing the orbits of certain distant Kuiper belt objects. While Planet 9 remains hypothetical, its possibility fuels the imagination and the search for new celestial discoveries. Imagine standing on the surface of a distant Kuiper belt object and feeling the faint warmth of the sun. Though it appears as just a bright star in the blackness of space, the sun's light travels billions of kilometers to reach these remote locations, a constant reminder of the vastness and connection within the solar system. Lastly, let's contemplate the potential for future exploration. As technology advances, more missions may be sent to explore the Kuiper belt, each one revealing new secrets and expanding our understanding of these icy frontier worlds. Perhaps one day, we'll walk, or at least remotely explore, the surfaces of these distant objects, gaining first-hand experience of their mysteries. As you drift into the gentle embrace of sleep, let these facts float softly in your mind, like stars scattered across the night sky. Each piece of information is a small spark, illuminating the vast and wondrous universe we are just beginning to understand. May the mysteries of Pluto, the Kuiper belt, and beyond cradle your thoughts, guiding you into a realm of dreams filled with endless possibilities. Good night,